This video will serve as a walkthrough for exercises 6.6 or 2.6 of Mr. John Coburn's Precalculus textbook. This chapter mainly focuses on solving basic trigonometric equations. So let's get started. I will be teaching you how to solve certain problems, but not everything will be taught, and that would already include numbers 7 to 11, 12. So we'll start at number 13. So first, we have to find the principal root of each equation. That basically means we have to solve for the missing value, or which is the variable. So for number 13, 2 cosine x is equal to the square root of 2. Divide both sides with 2, we get cosine x is equal to square root of 2 divided by 2. So arc cosine of the square root of 2 divided by 2 is equal to pi over 4. So that is the principal root of number 13. I'll just move this over here. Okay. For number 14, 2 sine x is equal to negative 1. Divide both sides with 2. So we have negative 1 over 2. X is equal to the arc sine of negative 1 over 2. X is equal to negative pi over 6. Okay, for number 15, negative 4 sine x is equal to 2 times the square root of 2. Divide both sides with negative 4. Whatever is multiplied to sine x or cosine x or tangent x, we eventually have 2 times the square root of 2 divided by negative 4. So in case that value with an arc sine, and we have negative pi over 4. For number 16, negative 4 cosine x is equal to 2 times the square root of 3. So cosine x is equal to negative 2 times the square root of 3 over 4. X is equal to the arc cosine of negative square root of 3 over 2. That's basically the simplified version of that value, which is equal to 5 pi over 6. Okay, let's move to number 17. Divide both sides with square root of 3. We have tangent x is equal to 1 over square root of 3. X is equal to the arctangent of 1 over the square root of 3, which is pi over 6. Number 18. Negative 2 times the square root of 3 tan x is equal to 2. Tan x is equal to negative 2 times the square root of 3 over 2, which is basically negative square root of 3, or what's next is, wait a minute, sorry. We have something like this, and in case this value with an arctangent, we have x is equal to negative pi over 6. Okay, that's for number 18. For number 19, sine x is equal to negative 3 divided by 2 times the square root of 3. X is equal to the arc sine of negative 3 over 2 times the square root of 3. That is equivalent to negative pi over 3. For number 20, negative 3 times the square root of 2 cosecant x is equal to 6. cosecant x is equal to negative 6 divided by 3 times the square root of 2. X is equal to the cosecant of the mentioned value. But because it's cosecant, we all know that what's available on our scientific calculator, that would always be only sine, cosine, tangent, and their respective arc versions. But for this one, this is basically the inverse of cosine. The inverse of sine. We basically reciprocate. So x is equal to arc sine of negative 3 times the square root of 2 divided by 6. Just interchange the numerator and denominator, and yeah, that's basically, they're basically the same. What made them different is the position of the numerator and denominator. The difference between each other is determined by their reciprocation identity. So for number 20, that would be negative pi over 4. Okay, so number 21, negative 6 cosine x is equal to 6. That would obviously be, if you divide both sides with negative 6, we get cosine x is equal to negative 1. X is equal to the arc cosine of negative 1. That would be pi. For number 22, for secant x is equal to negative 8, secant x is equal to negative 2, x is equal to the arc secant of negative 2, which is basically arc cosine of negative 1 over 2. That means x would be equal to 2 pi over 5. Okay, for number 23, we have 7 over 8. Multiply both sides with 8, we have 7 cosine x is equal to 56 divided by 16. That would basically be for a while. I need a few seconds to analyze this. We could simplify the fraction. Divide both sides with 8, I guess. That would be 7 over 2. And if we divide both sides with 7, that would be something like that. And eventually, cosine x would be equal to 1 over 2. X is equal to the arc cosine of 1 over 2. That would be pi over 3. Okay, for number 24, negative 5 over 3 sine x is equal to 5 over 6. Negative 5 sine x is equal to, let's make this positive already. The negative sign would be transferred at the right side of the equation. So it's negative 15 over 6. Sine x is equal to negative 15 over 6 divided by 5, which is equal, eventually, which could be described as something like that. And of course, cancellation. Negative 3 over 6 would be negative 1 over 2. X is equal to the arc sine of negative 1 over 2. X is equal to negative pi over 6. Okay, that's number 24. Let's move on. Carry on with 25 to 28. So This time, we divide both sides by 4. So sine theta is equal to 1 over 2. Theta is equal to the arc sine of 1 over 2. Theta, therefore, is, I think this is pi over 6. Yeah, I suppose so. For 26, number 26, pi tan x equal to 0. By the way, for number 25, I do suspect that because sine theta is equal to 1 over 2, based on the unit circle, with a usual, let's say, the cosine theta, since we all know that for the usual xy, that's in the context of this lesson, cosine theta would be equal to x and the sine theta would be equal to y. With that in mind, say sine theta is 1 over 2. What would be the other value? What would be the value of cosine if sine is 1 over 2? That would be the square root of 3 over 2. And this is an equivalent of pi over 6. Now this is for quadrant 1. Since we'll be assuming that both cosine and sine theta are positive. The values, the operation, whether the cosine or sine is positive or negative, that would depend on the quadrant where it is situated. So we won't be expounding too much on that since I've already discussed it in the previous videos. You can just check it out. The earlier chapters of this book, I explained them pretty much with the best way I could. So yeah, let's proceed with number 26. We divide both sides with pi. So 0 divided by pi, x is equal to the arctangent of 0 divided by pi, which is basically 0. Okay, for number 27, divide both sides with 10, I guess. Yeah. So negative 5 times the square root of 3 divided by 10. Cosine theta is equal to negative square root of 3 over 2. And theta would be equal to the arc cosine of this negative square root of 3 over 2. Theta would eventually equate to 5 pi over 6. Okay, number 28. Divide both sides with 4. That would eventually be like this. I've already simplified it. Pi is equal to the arctangent of the square root of 3. We eventually get pi over 3 as the final answer. That's the principal root for number 28, I suppose. Yeah. Okay, that's for 28. 29 and 30. Let's answer 29 and 30. I won't be able to answer to number 31. I couldn't solve it correctly, so let's just consider that a bonus. For number 29, transpose negative 3.5 to the other side of the equation. We have something like this. And divide both sides with 9. We get something like this. 4.5 over 9 is basically 1 over 2. And x is equal to the arc sine of 1 over 2. X is equal to pi over 6. I certainly believe that this is one of the solutions for number 29, but I'm really not sure. I'm already telling this you now. You have to know this since I do have my limitations as a senior high school student. I'm not really that much with precalculus, but I'm doing the best that I could to deliver what I understood in class. So for number 29, I'm not really sure how to find the other solution, but according to the book, the answer key, the other solution is 5 pi over 6. So that's for number 29. I won't be looking for all the solutions, so that's already a disclaimer. I hope you're taking note of it. So, yeah. I don't claim any responsibility for any misinformation. I've already told you that I'm not exactly a teacher that's certified to teach, but I'm doing the best I could. For number 30, 6.2 cosine x is equal to, if you transpose 4 to the other side, we have 3.1. Divide both sides with 6.2, we have 1 over 2. 3 over 1 over 6.2 is basically 1 over 2. So x is equal to the arc cosine of 1 over 2. X is equivalent to pi over 3. Okay. I do certainly believe that if you want to look for the other solutions of a specific trigonometric equation, for instance, in number 29, example, this is a unit circle, a mere illustration. This is where pi over 6 is. This is quadrant 1. This is quadrant 2. Basically, this is where this is where 5 pi over 6 is situated. And yeah, if you can observe, this is a specific pattern. For example, if your first solution is, say, pi over 3, then your other solution would be at the other side, or at the other quadrant, the quadrant next to it, which would basically be 2 pi over 3. If your initial solution is, or the first solution that you found is, say, pi over 4, then the other solution would be 3 pi over 4. I'm not sure, but that's just my mere hypothesis on how to look for the other solution. But you can always believe in something that's actually proven. That's just an idea that I want to share. For number 30, yeah, that's everything that I could write for number 30. I believe that there are more solutions, but I won't write it anymore. For number 32, okay, 1 over 2 secant x is equal to, transpose negative 3 over 4 to the other side, we eventually get negative 4 over 4, which is negative 1. Secant x is, multiply both sides with 2. So we get secant x is equal to negative 2. X is equal to the arc secant of negative 2, which is, you have to reciprocate. So make, because secant is the inverse of cosine, then if we want to express x in cosine, then you have to reciprocate the value that secant initially encases. So you have negative 1 over 2 there. X is equal to 2 pi over 3. This is one of the solutions. Okay, number 33, I won't be answering that. As you can see, my solution is an epic fail. Number 34, sine x is equal to, because these are negative, make them positive. We have 55 times the square root of 3 divided by 110. X is equal to arc sine of 55 times the square root of 3 divided by 110. That would be pi over 3. Okay, let's move on to number 35. We have 4 cosine raised to 2x equal to 3. Cosine raised to 2x is equal to 3 over 4. To remove the raised to 2 in cosine x, square both sides. X is equal to the arc cosine of the square root of 3 over 2. We eventually get pi over 6. For good reason. Initially, we knew that cosine x is the square root of 3 over 2. I said earlier that if the cosine, if I'll just say this in another way. Cosine theta, if it's exactly the square root of 3 over 2, then the sine or the y value would be 1 over 2. And this would obviously correspond to pi over 6. Hence, we have pi over 6. And according to the book, there are other solutions. That would namely be 5 pi over 6, 7 pi over 6, and 11 pi over 6. Yeah. Let's move to number 36. Square root of sine raised to 2x is equal to the square root of 1 over 4. Okay, wait a minute. Sine raised to 2x is equal to 1 over 4. If you want to eliminate the square of sine x, that would we would have to, on both sides, install a square root sign. So we eventually have like something like this. X is equal to pi over 6. Okay, number 37. Tan raised to 2x is equal to 3. Square root on both sides. Tan x is equal to the square root of 3. X is equal to the arctangent of the square root of 3. X is equal to pi over 3. Okay, number 38. Secant raised to 2x is equal to 2. Square both sides. We eventually have secant x is equal to the square root of 2. X is equal to the arcsecant of the square root of 2. X, because secant is the inverse of cosine, so write cosine and reciprocate the value it secant initially encases, and we would have x is equal to pi over 4. I do believe there are other solutions, so I just keep watch of it. For number 39, cosecant raised to 2x. Divide both sides with negative 4, we have positive 2 at the right side of the equation. Square both sides as usual. Usual protocol. X is equal to the cosecant of the square root of 2. X is equal to the sine or the arcsine of 1 over the square root of 2. That would eventually be equal to pi over 4 and other more solutions. Okay, number 40. Cosine raised to 2x is equal to 3 times the square root of 3 divided by 6 divided by square root of times the square root of 3. That would eventually be 1 over 2, I suppose. And square both sides. Okay. could actually write this way. Won't be so hard. X is equal to pi over 4. There are more solutions. Numbers 41 and 42 are skipped. As you can see, I don't know how to solve them. As well as numbers 43 to 50, 51, all the way to 64, 65, 66. Okay, we'll resume with solving number 67. Yeah, I think this part would be the last that I could solve. Numbers 67 to 74. Everything else I wouldn't be able to do. Okay, instructions say that you have to solve each equation using a calculator and inverse trig functions to determine the principal root. So we won't be graphing. We have to clearly state the principal root and the all real roots. But for this specific part of the exercises, I will only look for the principal root. I'm not really sure about how I'm supposed to look for the other real roots, so technically I'll be answering A only, not the B of each number. So, for number 67, 3 times the cosine x equal to 1. This would divide both sides with 3. X is equal to the arc cosine of 1 over 3. X would eventually be approximately 1.2310. That's the principal root for number 67. 68. 5 sine x is equal to negative 2. Sine x is equal to negative 2 over 5. Sine is equal to the arc, x is equal to the arc sine of negative 2 over 5. X is equal to approximately negative 0.4115. Number 69. The square root of 2 times the secant x plus 3 equal to 7. Transpose 3 to the other side. We have 4. Secant x is equal to 4 divided by square root of 2. X is equal to secant, the arc secant of 4 over square root of 2. X is equal to the arc cosine of square root of 2 divided by 4. X would eventually be approximately 1.2094. Okay, number 70. Transpose to the 2 to the other side. We have 9. Divide both sides with square root of 3. X is equal to the cosecant of 9 divided by square root of 3. X is equal to the sine of square root of 3 divided by 9. X would eventually be approximately 0.1937. Number 71. 1 over 2 sine 2 theta is equal to 1 over 3. Sine 2 theta is equal to 2 over 3. Hang on. Okay. This is pretty unusual. We have sine 2 theta. I think this is a double angle identity, or at least something associated with the term. We eventually divide both sides with 2. After all that, we have 0. Theta is approximately 0.3649. That's for number 71. For 72, we multiply both sides with 5, divide both sides with 2. Express 2 theta with arc cosine 5 over 8. Theta is equal to approximately 0.4478. Number 73. Negative 5 cosine 2 theta na minus 1 is equal to 0. Transpose 1 to the other side. I won't be speaking too much right now. Just follow along and you'll be fine. Divide both sides with the 2. So we have all this. That would be approximately 0.8861. Number 74. 6 sine 2 theta minus 3 equal to 2. Transpose 3 to the other side. That would be 5. Sine 2 theta is equal to 5 over 6. 2 theta is equal to the arc sine of 5 over 6. Theta is equal to the arc sine of 5 over 6, all divided by 2. That would be approximately 0.4926. Okay, that's it. We'll end in number 74. This is everything that I could answer for exercises 6.6 or 2.6 in the Philippine edition. 6.6 is for the PDF. I hope you've learned something, at least, from what I've taught. Thank you for watching.